Okay, so let's look at another example where all we're doing is changing our period. We're not adding in a phase shift or a vertical shift yet. We can see that immediately because I don't have anything added inside the parenthesis. I've got something multiplied but not added. And there's nothing added or subtracted outside. There's no K. I do have a little something happen here with a little negative out front we're going to have to think about. Okay, so we approach this the same as the rest. It's always the same process. Our amplitude is always the absolute value of A. A is the number multiplying your sine or cosine. In this case, that's -2. The absolute value of -2 is +2. Amplitude's always positive. Okay, our new period is always the old period, 2 pi, divided by b. B is the number multiplying x. So 2 pi over 3. We're going to have some fractions in this one. Our phase shift is always the opposite of c over b. In this case, c is 0. So no phase shift. And our vertical shift is always up or down by k. K equals 0. There's no vertical shift. Okay, we play our start and end games. It's always the same game. Start. Inside equal to 2 pi. Sorry, inside equal to 0. End. Inside equal to 2 pi. Because that's where regular old cosine starts and ends. That's one complete cycle. So by inside, we mean what's in the parentheses. 3x equals 0. 3x equals 2 pi. Here we get x equals 0. That will always be the same as your phase shift. This is just a second check. And end. Just divide everybody by 3. We get x is 2 pi over 3. End minus start will always equal the period. 2 pi over 3 minus 0 is 2 pi over 3. Always do those two checks. It's really just, we could, I could skip start and end. I could say, here's my start. And then I could take that number, whatever I get there, and add the period to get end. End is always the phase shift plus the period. This is a simpler way to do it, and it gives you that built-in check. And my scale is always the period over 4. So I've got here 2 pi over 3 over 4. So that's 2 pi over 3 times 1/4. So we're going to have to do a little bit of fraction work here. I could call that 2 pi over 12. Or I could do a little canceling here. Cancel the 2 and the 12 and get pi over 6. So my life is going to be much easier if everybody has the same denominator. I've got a 3 and a 6 here. There's the 3 also. Let's make everybody have the LCD, the least common denominator, in this case 6. So I want to multiply top and bottom here by 2 and say my end is 4 pi over 6. And same thing with my period here. 4 pi over 6. Then everybody has a denominator of 6. And this is really just 0 over 6. I mean, I can write that if I want, but it's not necessary. Okay, we draw a nice pretty sine wave, but we're graphing cosine. And they still have the same basic shape. There's no vertical shift, so my x-axis is the midline. That comes right through the middle. We'll see later, when we do have a vertical shift, all that changes is the midline will no longer be the x-axis. It will be our shift. We'll still draw in this midline, but it won't be the x-axis. It might be y equals 2. Okay, now, who are we graphing? We're not graphing cosine. We're graphing negative cosine. So we got to think about this for a minute. Let's take a moment and think. Sine of x, his graph looks like this. Here's a start and an end. That's one complete cycle. That's 2 pi. That's regular old sine. Regular old cosine goes like this. Let me try to draw him on the same scale there. Two pi. Cosine starts and ends at crests. What if these were negative? All they would do is get flipped over vertically. So negative sine, instead of going up, is going to start by going down. It's this guy flipped over. Negative sine still starts and ends at intercepts, but it's going down. Negative cosine is going to be this guy flipped around like this. So instead of starting up, he's going to start down. He would look like this. So that's what we're going to be starting and ending at. Troughs, not crests. So, like here, if we were to look along this graph, sine, this would be a perfectly good start and end for sine right there. That's what regular sine looks like. Cosine goes from here to here, from crest to crest. That's what a cosine would look like. A negative sine would go from here to here, starting and ending at the intercepts, but going down instead of up. We have negative cosine. So negative cosine would start and end at troughs. So here's going to be our start and our end. And we could have picked any of them. I could have said here and here, start, end. Doesn't matter. That's why we drew a bunch, so we'd have some choices. I know how to label those. 0 and 4 pi over 6. Wait, 0, that's something special. X equals 0 is the y-axis. There's my y-axis. And now I just count. Remember, in every period, like in this region here, I'm counting 4 spots. The trough, an intercept, a crest, and the next intercept. And then this guy is part of the next group of 4. And I'm counting by this. I'm at 0, 1 pi over 6, 2 over 6, 3 over 6. Oh, look at that, 4 pi over 6. It matched up perfectly. If it didn't, if I had messed up somewhere, that might be the wrong number. Maybe that would be 7 over 6. And I would look and go, oh, I've done goof. Okay, we count backwards. Negative 1 over 6. Negative 2 over 6. Negative 3. And negative 4 pi over 6. The last thing we got to put on, the thing people tend to forget, is our amplitude. Amplitude is how high and low we go. We already took care of the negative. See, we got that negative there. We took care of that by starting and ending at troughs. We've already dealt with the negative. We're not going to put a negative up here. This is still the positive side. This is still the negative side. And what was our amplitude? 2. So our highest is at 2. And our lowest is at negative 2. I'm going to squeeze that in there. And there is our graph. And that's a good place to stop.